Midas NFX Lecture 7 Transient Dynamics Mode Superposition Method. So this is the second method to solve transient dynamics problem, an impact problem. We give it a name and import the CAD file. So this is the step 1. For step 2, we will choose the material from the database, which is the 1020 mild carbon steel. So this is a loading of material, and we'll connect the material with the geometry. So actually this step is to assigning a material to the geometry. So we load the material and assign the material to the geometry. So we finish with the second step. For third step, we'll mesh the geometry, and the mesh size will be 10. So we finish with the third step. For the step 4, constraint is on statics. So we choose constraint and choose the entity to be face, and select the bottom surface to be totally fixed. And now for the loading, I'll place a load which is dynamics load. So I choose dynamics. This is a transient load, time dependent force. First of all, I'll choose surface of the load, direction of the load, magnitude of the load, multiplied by a time curve. Because this is a dynamics problem, the loading is an impact loading. So from time 0 to time 005, the force is 10 Newton, but at time 0.06, the force is released until 1 second. So at 1/20th of a second, the force is applied on this surface, and then the force is released, and for the rest of the time there's no force. So it is called an impact force. So for the step 4, we define a constraint and a dynamic force, which include the face or the surface of the load, the direction of the load, and the magnitude of the load, and also a time profile of the load, impact load. So for step 5, we'll include a transient dynamics problem, model superposition. So it is in other. So give it a name and choose the proper type to be model transient response. So this is the model superposition method for solving transient dynamics problem, and this is a direct integration of time method for transient dynamics problem. And in lecture 6 we talk about direct integration method. For now, in the lecture 7 we will talk about model superposition method for transient dynamics. So for the setting, solution setting, we have structural damping and also modal damping for each vibration frequency. But I'm not going to place any damping on it. But we have to define the integration time. We give it a name and the total time for integration for calculation, and the number of steps. I'll divide 1 second into 100 steps, and I'll add the procedure to the solution setting, and now I can perform the analysis, and the solution will cover 100 steps. And during the process, the software will calculate maximum displacement for the structure. So you can see that after the force is released, the structure vibrates, undulate to and fro, left and right. So I'll look at step 100, which is the last step. We can see that it is undulating or vibrating to and fro, left to right, after the force is released. It's vibrating like that. So it is an impact force, a very short impact force, followed by a free undulation of the hammer. And now we are going to probe the numerical value of the displacement, and then we will extract the data for displacement at a certain node point. You can choose other entities, but there's only node point available, so I choose this point on the surface of the hammer, which is 3592. It is the ID number of the node here. So I let it calculate the table for displacement for the 100 steps, and I'll let it display the graph. And you can see that the x-axis would be the steps, number of steps, and y-axis to be the displacement of this node point. And you can see that the hammer undulates or vibrates to and fro, left and right. So this is the displacement of the surface of a hammer. So this is a transient dynamics problem solved by model superposition method, where natural vibration modes are calculated in background mode, and the dynamics problems are solving by linear combinations of these natural vibration modes. So this is called mode superposition principle for solving transient dynamic problem. So I suggest that you compare the method of lecture 6 and lecture 7, so that you are aware of the two different methods for calculating the transient dynamics method. The first is direct integration method, and the second is mode superposition method. And these two methods are very important, so you might want to take a look at the theoretical manual. So this is lecture 7 for Midas NFX.